Welcome to Lecture Online, and here's an interesting problem for us to try and see if we understand relativistic velocity, time, length, and so forth. All right, so let's say you're in the spaceship, you're in this observer B, and you're trying to make it back to base. And the reason why you're trying to make it back to base is because you're being pursued by the evil empire, and luckily you have a really fast spaceship, a spaceship that can have a Lorentz factor as much as 22.4 at maximum speed. I'm not going to tell you what that is. That is a certain velocity. We don't know what the velocity is. And let's say that the base is at a distance of 2 times 10 to the 16 meters as observed by a person on the base. So the person on the base is looking back through a telescope, see what's going on, and sees the spaceship, your spaceship, trying to make it back to base and at that speed. And the question is, how long will it take you to get there? How long will the time be for the person, for you, to get to safety? And of course, as observed by a stationary observer, the distance is 2 times 10 to the 16 meters. But since you're moving really fast, that distance will be a lot shorter because we're moving at a very high velocity. So what will be the distance as seen by you? And of course, since you're traveling at a velocity probably pretty close to the speed of light, it'll then take you whatever that distance is divided by the speed of light to get there. Because remember, that distance is equal to velocity times time, which means that the time is equal to the distance divided by the velocity. So what we're going to do is we're going to figure out what the distance is as seen by you, then divide that by the velocity which you're traveling, which is probably really close to the speed of light. And then from that, we should be able to figure out how long it's going to take in your reference frame to get to base. Now, first of all, let's find out what d sub a is in terms of light years. Let's find out what 1 light year is equal to. So 1 light year, that's the distance, is equal to, and remember, distance is velocity times time. So 1 light year is the velocity of light times the time that light takes to travel for an entire year. So that would be equal to c times 1 year. All right, and c is equal to 3 times 10 to the 8 meters per second. And a year, of course, we have to convert that to seconds. A year is 365.25 days. And per day, there's 86,400 seconds per day, which means we converted a year to seconds by doing this product here. And let's go ahead and see how far it is for 1 light year. So 3e to the 8 times 365.25 times 86,400, and that is equal to 9.467 times 10 to the 15th, and that would of course be a light year. That would be in meters because everything else would cancel out, so it would be in meters. So how far is the distance to the base as seen by an observer on the base in terms of light years? So distance for A is equal to 2 times 10 to the 16th meters, and that is of course the meters per light year, right? This is the meters per light year, and so this is equal to 9.467 times 10 to the 15th meters per light year. So which will give us the number of light years. The distance is that between you and the base as observed by the observer on the base. So we take the inverse of that times 2, and we get 2.11. So this is equal to 2.11 light years. So you have 2.11 light years to travel to get to base. You're being pursued by the evil empire. And of course, at the speed of light, well, it would take you 2.11 years, according to the person on the base, to get there. So they think you're in trouble. Can you outrun the evil empire for more than 2 years before you get to base? But you say, not so fast, because in my reference frame, that distance isn't as far, because everything shrinks when you travel to space really fast. We know that the length is equal to L sub naught times the square root of 1 minus v squared over c squared. Now, which is L and which is L sub naught? So let's go ahead and try to do that in terms of A and B. So L sub naught is the length as seen by someone at rest. That would be as seen by someone at A. So we can go ahead and this would be L sub A. And L is seen by a person who's moving in reference to that distance. And so that would be L sub B. And L sub B will be much smaller than L sub A by this factor. Now, can we convert that to the Lorentz factor? Yes, we can, because we know that the Lorentz factor, by definition, is 1 over the square root of 1 minus v squared over c squared. So if we know that, we can then say that 1 over that is equal to 1 over gamma is equal to the square root of 1 minus v squared over c squared, which means that this radical here can now be replaced by 1 over gamma, which means that the length as seen by you is equal to the length as seen by somebody at the base times 1 over gamma. In other words, it is 2.11 light years divided by gamma, which at maximum speed you can go such that the gamma will be 22.4. So according to you, it's not nearly as long. We take that distance divided by 22.4 and we get equal to 0.0943 light years. So according to you, it's not nearly as far. And since if gamma is equal to 22.4, you know that your velocity is going to be very, very close to the speed of light. Which other words, the time that it will take you to get there will be this many years. So the time will be equal to 0.0943 light years, which is the distance divided by the speed of light, because time is distance divided by velocity. And so in this case, that will be 0.0943 years. So let's convert this to months. So we have months versus years. We have 12 months divided by year. So we have 0.0943 years times 12. And so that is equal to 1.13 months. And if we then convert that to days, roughly speaking, there's roughly 30 days in a month. So we have 30 days divided by 1 month. And so that's times 30. That would be roughly 34 days. So you're not as worried. All you have to do is outrun the even empire for another 34 days at maximum speed, and you'll get to base, which is quite amazing because according to people on the base, they think it's going to take you more than 2 years to get back home. But you know that if you just keep the engines going and humming at 22.4 for the Lorentz factor, you'll be home in 34 days and leave the evil empire in the dust. And that's how we do that.